Okay, so now this is the second part of the solving quadratic expressions and quadratic equations. From the previous video, we solved quadratic expressions wherein we used factoring, and this time we will be focusing on quadratic equations. But before that, let's answer the last three items that was given in the previous video. So for number one, we have 6x squared minus x plus 1. So if we apply the, the skills that we learned from the other part, here we multiply the coefficient of x squared, which is 6, to the constant term, which is in this case 1. So we have here x squared minus x plus 6. Then finding the factors of the constant term, which is 6. So the factors are 1 times 6 and 2 times 3. So we choose which pair of these numbers will give us the coefficient of the middle term, which is negative 1. So that will be 2 and 3. But since our goal is a negative 1, so we set 3 to be negative and 2 to be positive. So, but the problem here is that when we add negative 3 and 2, it becomes negative 1. But if we multiply negative 3 and 2, it is not equal to the constant term, which is 6. It becomes negative 6. So we can say that this cannot be the factors of x squared minus x plus 6. So we can say that this is not factorable. We can confirm this by using the quadratic formula, which we will learn later. So we will go back to this item later on. Next, for number 2, we have 4x squared minus 20x plus 25. So if we apply the same skill that we used a while ago, so since the x squared has a coefficient which is 4, so we multiply it to the constant term, which is in this case 25. So we'll get x squared plus minus 20x plus 100. Then, getting the factors of the constant term, which is 100, we list them down. So that's 1 times 100, 2 times 50, and 4 times 25, 5 times 20, and 10 times 10. So among these factors, we will choose a pair that will give us a sum of the, which is equal to the middle term, which is, in this case, that will be 10 and 10. Okay? So since the middle term is a negative 20, both 10s should be negative. That will be negative 10 plus negative 10 to give us a negative 20. And then, if we multiply negative 10 times negative 10, that gives us a constant term, which is 100. So, we will use negative 10 and negative 10 for the factors. Okay. So, we have here x minus 10 times x minus 10. But this is not yet the final answer. So, since at the beginning, we multiplied the coefficient of x squared to the constant term. So we will divide again, this time, the constant, which is 10, divided by 4, which is what we multiplied a while ago. So x minus 10 over 4 times x minus 10 over 4. Okay, simplifying it. So since 10 and 4 are both divisible by 2, we got x minus 5 over 2. And then, applying the shortcut that we learned from the last video, this will be 2x minus 5. So this denominator multiplied to x, we get 2x minus 5, and then the other side is also 2x minus 5. Alright, so these are the factors of 4x squared minus 20x plus 25. Now for number 3, we have 2x squared plus 5x plus 3. So same steps, so multiply the constant and the coefficient of x squared. So that's 2 times 3. We'll get x squared plus 5x plus 6. So now finding the factors of 6, that's 1 times 6 and 2 times 3. So choosing which pair gives us a sum of 5, we have 2 plus 3 is equal to 5. Multiplying it 2 times 3 gives us 6. While at the same time, 1 and 6 can also give us a sum of 5 by adding 6 and negative 1, which is 5. In this case, I wrote it as 6 minus 1. So that's also 5. But if we multiply them, 6 times negative 1 gives us negative 6, which is not the same as this constant term. So therefore, we will use the first pair, which is 2 and 3. So we have here the factors x plus 2 times x plus 3. But since we multiplied the coefficient of x squared a while ago to the constant term, we will divide it this time. So we have x plus 2 over 2 times x plus 3 over 2. Simplifying it, x plus 2 over 2 is the same as x plus 1, and this 2 times x, we get 2x plus 3. So the factors of 2x squared plus 5x plus 3 is x plus 1 times 2x plus 3. So now we have answered all the exercises from the last video. Let's proceed to the next topic. So we now will focus on quadratic equation. So again, the difference between expression and equation is, of course, the existence of the equal sign, basically. So from the standard form of a quadratic equation, we have ax squared plus bx plus c. So note that this ax squared plus bx plus c was the same form as your quadratic expression, but this time we equate it to something else, in this case with 0. This is the standard form of the equation of the quadratic equation. So solving quadratic equations means finding the value or values of x that will make the quadratic expression, which is ax squared plus bx plus c, be equal to 0. Okay? So we can do this in 3 ways. One is by factoring, which means applying the skills that we had. And 2, completing the square. And 3, quadratic formula. So let's start by using factoring. So let's use one example from our previous video. We have here 3x squared plus 30x plus 72 equals 0. So we factor out the 3 since all terms here are divisible by 3. So that means 3 is a common monomial or a common factor. So we extract it as 3 times x squared plus 10x plus 24 equals 0. Then we will do factoring for this expression here, x squared plus 10x plus 24. So the 24, the factors are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So choosing a pair, that gives us a sum of 10, and a product of 24, that will be 4 and 6. Okay, we ruled out 2 and 12 because if we multiply 12 and negative 2, that gives us a negative 4. So we'll go with 4 and 6. So the factors now will be 3 times x plus 4 times x plus 6 equals 0. So now, since we are trying to solve for the values of x that will make this left side of the equation be equal to 0, we need to find those numbers. Okay, so how do we do that? So we equate each factor to 0. So of course, we do not need to equate 3 to 0 because it has no variable x. So we focus on the factors that has the variable x. We have here x plus 4 equated to 0, and then x plus 6 equated to 0. So what's the concept behind this? Why are we equating it to 0? Because knowing that this is multiplication, that's 3 times x plus 4 times x plus 6, if one of these factors is equal to 0, the whole thing will be equal to 0 by multiplication. Right? 3 times 0 times anything is equal to 0. So we are trying to find that value of x that will make this equal to 0. So we have x plus 4 equals 0. We transpose the 4 to the other side of the equation. We have x equals negative 4. And then doing the same thing to the other factor, which is x plus 6, equated to 0, we have x equals negative 6. So therefore, the two values of x that will make this equal to 0 is, or are, negative 4 and negative 6. Alright. So now, next we do this by completing the square. Alright. So what do we mean when we say completing the square? So the goal is to create a perfect square trinomial. Okay. So we'll do this in this example. So x squared minus 6x minus 27 equals 0. So we've already answered this from our previous video. So we'll just use a different approach this time. So the first step in completing the square is to separate the constant term c. Okay, so in this case, since we have an equation, we can separate it by transposing it to the other side. So we have here x squared minus 6x. So since we transpose negative 27 to the other side, it changes sign. So it becomes positive 27. Okay. Then step 2, we add b over 2 quantity squared to both sides of the equation. Okay, what's b over 2 quantity squared? B is the coefficient of the middle term, which is x. So which is, in this case, b equals negative 6. So we add it to both sides. So we have here x squared minus 6x plus b over 2 quantity squared, wherein b is negative 6. We have negative 6 over 2 quantity squared. We also add it on the other side. So that's 27 plus negative 6 over 2 quantity squared. Then we simplify both sides. So negative 6 over 2 is negative 3. Square it, that's positive 9. And then the other side, the same. Negative 6 over 2 is negative 3 squared, that's 9. So we have here x squared minus 6x plus 9 equals 27 plus 9. So we can use factoring on the left side. Okay, so since this is now the target, the goal of making a perfect square trinomial, so we have x squared minus 6x plus 9. So we can use this format, x plus b over 2 quantity squared. So remember that b is negative 6. So x plus negative 6 over 2 and then quantity squared. Okay, so equals 27 plus 9 equals 36. So simplify further, so negative 6 over 2 is negative 3, so we have x minus 3 quantity squared equals 36. Okay, but since our goal is to find the value of x, okay, so we solve for the square root of both sides of the equation. So to eliminate this squared here, so we need to get the square root. So whatever we do with the left side, we also do it with the right side. So we have square root of x minus 3 quantity squared equals square root of 36. So we can extract this from this equation, this square root sign. So we have x minus 3 equals square root of 36 will be plus or minus 6, because 36 is a product of positive 6 times positive 6 or negative 6 times negative 6, right? So the square root of 36 is either plus 6 or negative 6, all right? So we now have here x minus 3 equals positive 6 plus or minus 6, sorry. So we transpose the negative 3 to the other side. So we have here x equals plus or minus 6 plus 3. This negative 3 transposed to become positive 3. So therefore, the two values of x will be x equals 6 plus 3, and the other one, x equals negative 6 plus 3. Simplifying it, we have x equals 9 and x equals negative 3. So those are the two values of x that will make the original equation equal to 0. All right. Then the last one is by quadratic formula. So you have to memorize this formula because you will be using it for a lot of times. So we have here x, the values of x will be equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so wherein, of course, the a, b, and c will be coming from the standard form of the quadratic equation. So let's use the same given from the completing the square. Okay, so where a is equal to 1, b is negative 6, and c is negative 27. Okay, so we apply it to the formula given here. So this is negative b, so that's why negative, and then b is negative 6. We just substitute it. Plus or minus square root of b squared. So b is negative 6 squared. Minus 4 times a, where a is 1, and c is negative 27. All over 2a, wherein a again is 1. Okay, then simplify. So negative times negative 6 is positive 6. And then plus or minus square root of negative 6 squared is 36. And then negative 4 times 1 times negative 27 will be positive 108. Okay, so over 2 times 1, which is 2. Then simplifying it further, 36 plus 108 is 144. Then continuing, so we have here the square root of 144 is 12. Okay, so we now have here x equals 6 plus or minus 12 over 2. Then now we separate. So we have here x equals 6 plus 12 over 2, and the other value is x equals 6 minus 12 over 2. Simplifying it, 6 plus 12 is 18, 6 minus 12 is negative 6, therefore the values of x will be 9 and negative 3. Okay? So now we go back to the previous example, okay, or exercise. So 6x squared minus x plus 1. So as we've shown a while ago, we cannot factor this, okay? So we said we need to use the quadratic formula to check if it's possible to solve this, okay? Let's try. So 6x squared minus x plus 1. So wherein a is 6, b is negative 1, and c equals positive 1. Okay, applying the formula. So we have negative of negative 1 plus or minus square root of negative 1 squared minus 4 times a, which is 6, and c, which is positive 1, over 2a, which is 2 times 6. Then simplifying, so negative times negative 1 is positive 1 plus or minus square root of negative 1 squared is 1. Then negative 4 times 6 times 1 is negative 24. Simplifying it further, 1 minus 24 is negative 23. So we know that we cannot get the square root of a negative number. So that will be imaginary. So in this case, we can say that there is no real number solution. Okay, because you cannot get a real number from a square root of negative 23. That will be an imaginary number. So you can say that there is no real number solution for this. Okay, so that's it.